So till now in the series of DBMS lectures, we have already discussed what is functional dependency, how to find out functional dependency from a given relation or table, what are different types of keys in DBMS, and how to find out all the candidate keys present in a relation when a relation is given and functional dependencies are given on that relation, right. So that part is very important in normalization, right. So today I am going to start normalization. We will discuss in this video, we will discuss what is normalization, what is need of normalization, right, and for which database normalization will be needed and for which database denormalization of the tables will be needed, right. And also we will discuss now what is the benefit, or you can say what are the advantages of normalization, what are the advantages of normalizing a table, right. So first of all, I am not going to tell you the definition whatever written in the books or net, the definition of normalization. We will discuss some problems if we take some relational schema or some table or a relation, then some problems in that relation and how to resolve those problems, then automatically you will get what is need of normalization and what is basically normalization, right. So let us take one example. I am taking a table, or you can say a relation, or you can say I am taking a relational schema, right. Suppose I am taking this relational schema, you can say I am taking this table or a relation named student, and in this table I am having these attributes of a student. I am going to store information of students, right, student ID, name, total credits of that student, or you can say marks, and a department name, building of that department, in which building that department is, and room number, right. All this information I am taking in one table. Now suppose I am inserting some data in this table C. Student ID is 1 and suppose name is Rahul, right, and total credit of this student is suppose 5 out of 10 I am taking. Department name is CSC and building is suppose B1 and room number is 101, right. Again I am inserting a second student and the name is Jia, credit 8, same department CSC, building would be B1 and room number would be 101. Like this, suppose I have inserted 6 student information and I want to store another student information. Suppose student ID is 7 and name is Vanshika and suppose credits are 8 and department is civil, right. So now you have to repeat the same information again, that is the building and room number, that is 110, fine. Like this, if you will insert the student information, then you have to repeat this information again. Suppose student is, again I am inserting a student and department of that student is CSC. Now again I have to repeat the building and the room number for this one. So this is what? Redundancy of the information, right. See, we are repeating this information again and again. You can see for this also, for this record also you are repeating this information. Here you can say if 2 students are in fashion designing department, then you have to repeat the building and the room number for both the tuples. Like this, suppose I am taking a only 8 entries, suppose millions or thousands of entries are there, right, and in thousands of entries maybe suppose 100 or 200 students are from CSA department. So for each record, for each row, what obviously you need to specify the department, that is okay, but with this department name you need to specify building and room number in all the 500 rows. Now what's the point of repeating this information again and again, right. So this is what? Redundancy. Why this problem occurs? Because I am taking a larger schema. I am going to store more information in one table only. Here I am taking only 1, 2, 3, 4, 5, 6 attributes. Suppose in this table also I am taking HOD, name, HOD, room number, and HOD you can say phone number. So for CSC 1 HOD would be there, right, and if students are 100 in CSE department, so for those all 100 students, you have to repeat the HOD name, or you can say the HOD information in all the 100 tuples. Now what is that? That is redundancy. So problem is what? Because of this larger schema. Now if we decompose our table into smaller tables, then maybe you can reduce the redundancy. Fine. And see, redundancy is the main, or you can say redundancy is the root cause for all the problems. Fine. Inconsistency, insertion problem, deletion problem, update problem, all the further problems will be arised because there is redundancy in your table. So if you reduce or if you remove the redundancy, see, I'm not saying that the normalization will remove the redundancy completely, no, but it will reduce the redundancy, it will reduce the duplicate data, right? So if we are able to reduce the redundancy, then obviously we are able to remove, or we are able to reduce the problems that will occur because of redundant data, right? Now what problems can occur if we have this data? If we don't have smaller tables, we have one larger schema where we want to store all the information in one table only, right? Then what the problem can occur? First problem is what is the redundancy problem. Now because of this, another problem can be there. Three main problems are there. One is insertion, updation and deletion. What we call is insertion anomaly, deletion anomaly and updation anomaly. Anomaly is what? Basically anomaly is what? When a data is having multiple copies, right, and at one place we update the data but we forget to update that same data in another place, right? So now we have what? We can't say that which data is correct, because at one place we have some other value, at another place we have some other value for the same data, right? So that is what? A data anomaly. So now let us discuss the first anomaly, that is insertion anomaly. What does that mean? See, if suppose I want to insert a department name or a department information in this table, right? Suppose I want to insert in a university, we have one more department, that is suppose mechanical, right? And room number of, sorry, the building is B1 and room number is 120, right? Only I want to insert the department information, but in this table you cannot insert this information. Why so? Because in this record, in this tuple, obviously you need to insert credits, student name and student ID, right? If you insert here null, 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 but SID is primary key, that cannot be null, right? So that would be problematic situation. We cannot insert information of a department until we have at least one student enrolled in that department. But that is a problematic situation. Maybe students are not there, students are still yet not enrolled in that department, but we have department information, but we are not able to insert that information in this table. Why so? Because we are taking all the information in one table only. Fine, that is insertion anomaly. I hope you got now what is insertion anomaly, right? We want to insert some information, but you cannot insert that information because for inserting that information you need to insert some extra information, right? And if you don't have that extra information, then you cannot insert this information in this table, right? So that is wrong, right? So that is insertion anomaly. Now second anomaly is what? Updation anomaly. Now suppose I want to update the room number, right? Or you can say that building of CSE department, right? Suppose I want to make this building, CSE department has been shifted from B1 to C1, right? Maybe suppose in C1 room number is 101, that's fine. Or you suppose in a room number is also 301. Now you have to update this information in all the tuples where the department is CSE department. Why so? Because while creating this table, this relational schema, what we have to insert the information of this department, right? Department name, building and room number once for each student of that department. And suppose in CSE department I have 150 students. So now in 150 rows you have this information, this redundancy, right? This complete information. So now in 150 rows you have to update this information. Here also C1 and 301. Here also you can say in CSE I have C1 and 301. In this table I have only 3 tuples having CSE information, but maybe when you are actually storing the information, the real world entities problem, right? When you are actually designing a database, then maybe you can have millions of records. In that case, that would be difficult to update in each tuple. And suppose by chance we have updated in 2 tuples and we forgot to update in this tuple, then that would be inconsistency. Here for CSE building is B1 and room number is 101. Here for CSE building is C1 and 301. Now which information is correct, we can't say, right? So that is what that leads to inconsistency problem. Our data is now in inconsistent state. So this is not a good database design, right? So that is what update anomaly. Now third is what? Delete anomaly. Now what is this delete anomaly? See, let us take one example. Suppose I want to delete this student information, that is 6, student ID is 6, name is Akash and credit 7, right? Now if you want to delete this information, then obviously you have to delete this complete record, complete tuple from this table. And so when you are going to delete this information, then automatically this department information will be deleted, right? And only one student is there in this department, right? But obviously when you are deleting a student, maybe student has left the college, it doesn't mean that we are going to delete the department from the college. Obviously that is not a case. So but when you delete this one, then we don't have any information of EC department left now. So that is what a delete anomaly, that is what problematic situation, right? That should not be a case. Yes, you can remove the student information, but this department information still exists in the college or in the university, fine. So this is what a delete anomaly. So now I hope you got all the 3 anomalies. Now how to remove, what is the solution of this problem? How can we solve these problems? See, suppose you decompose this table into 2 tables like this. Now suppose I have decomposed, or you can say I have divided this table into 2 tables. One is student, one is department. Student table is having information student ID, name, credit and department name, and department table is having information of department, that is department name, building and room number. Now you can see we have removed all the information, these problems. Why? So because we have removed the redundancy. See, CSE, the information for CSE department I am storing only once, building B1 and room number 101. Here we have to store for each student, but here only once. Civil also once, fashion designing I am storing only once, and ECE also for once, not for each student. If in CSE department we have 100 students, then obviously we will store the information of 100 student in this table, but this information, building and room number, no need to repeat this information for all the students. Just make a separate table and store that information only once, fine. See now, here obviously these 2 tables will be related with each other, because we are working with relational database management system. There all the information is stored in the form of relation, and each relation are related with each other, having some relation with each other, right? How these tables are related? With the help of foreign key. I haven't discussed foreign key. I will make a proper video with help of an example. I will tell you what is foreign key, but for now, see, just keep this thing in your mind that foreign key is used to establish the relation between tables, right? Now see, here also I have department name, here also I have department name, right? So now if you are dividing this larger schema into smaller schema, or you can say into smaller tables like this, then obviously you have to write down some rules, like if we are making a table department name, building and room number, then obviously you should write a rule that department name will act as a primary key in this table, right? It's not like that department name, we don't have any primary key in this relation. Fine. Now see, department name is primary key for this relation. So now this department name would be foreign key, right? We are referring to this department name will be referring to here, to this primary key in this table, right? I'll discuss in detail what is foreign key, right? But here you can see directly see that to establish the relation between this and this, we are going to use department name. So department name is what? Foreign key. Now what about insertion anomaly? Now suppose I want to insert this information, any department information. So no need to do anything, directly you can insert this information, mechanical, B1 and 120, right? Obviously we can insert the information in this department table, no need to insert any information regarding of this mechanical department in this student table, right? But it's not like that we have divided this table, so we can delete any record from the table, we can insert any record from any table, right? Here also we have some referential integrity constraints, right, that will be applied on foreign key, right? That constraints we will discuss later. Fine. But here like this you can insert this, fine, but here we will not able to insert the data, right? Now what about update anomaly? See, suppose I want to insert this CSA department, building is C1 same and this one is 301. So that's it, you have to update only one tuple, not all the tuples like in this case. So we have solved the updation anomaly problem, right? Now what about this delete anomaly problem? Same, suppose I want to delete a record of the student, right? So simply you can delete this tuple. It doesn't mean that we have deleted the information of the department. We still have EC department, information of EC department in this department table, right? We have only deleted this information from student table, fine. So we have removed all the 3 anomalies by decomposing this table into 2 tables, right? So this is what normalization. So normalization, how you can define? Normalization is a process of making the table free from insert, update and delete anomalies, and obviously save space by reducing the redundant data or duplicate data. That is what normalization. Fine, I hope now you got, or you can easily write down the definition of normalization. And as well as we have divided this into smaller tables, then you can say that it will simplify the queries, right? You will have to write down simple queries, fine. Now it's not like that we need normalization on the data every time. Sometimes it is better to use denormalized data, fine. When, see, I hope you have heard about OLTP and OLAP. If not, then I'll discuss later in a complete video. It is what? Online transactional processing and analytical processing, fine. Here in this case we need normalized data, because this is what you can say transactional means day-to-day transaction, insert, update and modify or modification of, or you can say deletion of the database, some data from the database, right? These queries are very frequent. So if these queries are very frequent, so obviously we want that these anomalies would not occur. So in OLTP system we need normalized data mostly, or you can say every time. In OLAP system, or you can say in data warehouse, when we are going to store huge data, or you can say data warehouse means there we are storing huge data or historical data, fine. Analytical queries means here we perform complex queries in which we used to join multiple tables to get the result, fine. So rather than dividing the table, because if smaller tables are there, then obviously you have to join the tables, so it's better that data would be in one table only, so no need of the joining of the tables, fine. So that is why in this case we need denormalized data. Basically data is stored in denormalized form to make the performance better, fine. But here the data would be in normalized form to get the performance better, So now I hope you got what is need of normalization, right? Or you can say what are benefits of normalization. First point you can write here is what? To reduce the redundancy from the table, right? If you reduce the redundancy, then obviously what it will compact the data. So obviously second point is to save the space. Benefits, in benefits you can write benefits of normalization, fine, and to reduce or to remove these anomalies, fine. Third or fourth point you can write as what? Normalization minimize the null values, fine. Obviously here if you will store some information and if you don't have another information, then you will store there null, null and null. Suppose I have student information but I don't have any department information, so here you need to store null, null and null, fine. So it will minimize the null values. Another point you can write is what? Normalization will simplify the queries, fine. Another point you can write down is what? It is important for these type of system, OLTP systems, where insertion, insert, delete and this update queries are accessed very frequently, right, by the end users. And another point you can write down is what? It simplifies the database structure. By looking at the structure or this table, you can easily understand, fine, what this table is all about, fine. If you have suppose one large table having 15 to 20 attributes like student information, department, HOD name, faculty information, then by looking at that table, at that schema, it would be difficult to understand. But if we divide that into 4 tables, like for student another table, for department separate table, for faculty separate table, for HOD separate table, then by looking at those tables, you can easily understand the schema, fine. And obviously that it will simplify the queries, because if you write down a simple query on this table, then that would be difficult, fine. We will discuss it when we will write down the queries, when we will discuss the relational algebra, fine. So searching, or you can say sorting and creating indexes will be faster after applying the normalization. So these are all some important points about normalization. Another point is what? See, decomposition of this table is also not so easy. To find the right decomposition is a very tough process, fine. Here this is simple table. By looking at this, you can easily find out that we will separate the student information in one table, we will separate this information, department information, in another table. That is very easy. But sometimes it's not so easy. To find out the right decomposition is also very tough, fine, because there could be some lossless decomposition and lossy decomposition, and that lossy decomposition we don't want. So what is that lossy decomposition and lossless decomposition? That also we will discuss later, fine. So that is also a very important point here, how to decompose the table, fine, so that data will not get lost. You will get a lossless decomposition. Now normalization is also having multiple levels, means multiple normal forms, first, second, third, BCNF, fourth, fifth, sixth normal form. Many normal forms are there, fine. So that also we will discuss one by one in later videos. So in next video we will discuss first normal form with the help of one example. So now I'll see you in the next video. Till then, bye bye, take care.